All right, today we are talking about three things. We're going to find asymptotes, we're going to find holes, and then we're going to do long division. Okay, none of those things are very difficult, especially the first two. We'll be able to work our way through that and move on to the next section. So, a vertical asymptote. We're going to start off by finding vertical asymptotes. A vertical asymptote is an invisible. I say invisible because you won't actually see it drawn on the graph, but it's there. Okay, you'll be able to spot them pretty quickly. An invisible break or line in a graph where the graph line approaches. I'm going to get even less technical and say gets really close to. But never touches. Okay, and that's just for vertical asymptotes. We can touch or cross a horizontal asymptote, but we're talking about vertical asymptotes. We're going to get really close to it, but never touch. Okay, so if you look at these examples down below, you can see hopefully a vertical break in my graph. For example, on letter A, where would you draw a vertical line that would split this thing up? At 5. If I drew a vertical line right there at 5, you wouldn't need to actually draw it, but you can draw that dashed line in there. That's why I say it's invisible. They're not going to actually draw it most of the time. Okay, sometimes they will with a dashed line, but if not, it's still there. To find vertical asymptotes, what we're looking for is dividing a number by 0. Okay, so if we do this thing and we get some number divided by 0 when I plug in, that's what's going to get us a vertical asymptote. Okay, so for example, on number 1, what we're going to do is we're going to take the bottom and set it equal to 0. Because if the bottom is 0, that's when I get a vertical asymptote. So if I were to solve that, I'm going to have a vertical asymptote at x is equal to what number? 5. Because if I plugged in 5, I would get 0 on bottom. It would be 2 divided by 0, and that's when I get a vertical asymptote because it's undefined. Okay, which graph down below has a vertical asymptote at 5? The first one. We did this one right here. Letter A, we said there was a vertical asymptote right there. So 1 and A go together. We found the vertical asymptote and then we matched it with the graph. Okay, number 2 says f of x is equal to 3 divided by x squared minus 16. So first thing we're going to do is take the bottom, set it equal to 0, and solve. So in this case, I got a factor. So I'm going to factor that thing into, or just set it equal and solve, I guess. So x squared is going to be equal to positive 16. So x is going to be equal to plus or minus 4. I have a vertical asymptote at x is equal to plus or minus 4. Vertical asymptote at x is equal to plus or minus 4. Which one of these graphs down below has a vertical asymptote at x is equal to plus or minus 4? D. You could draw a line right here at 4 and negative 4, and it would match up, so that is graph D. Everybody kind of see what's happening? Try 3 and 4, see what you can do with that. Find the vertical asymptotes and then match it with the graph. So let's look on number 3. Sophia, what'd you do on 3?
I set the bottom equal to 0.
Yep. Set,
and I factored it.
good. Set the bottom equal to 0 and factor. How'd you factor that thing?
X minus 3 and x plus 2.
X minus 3, x plus 2. She's going to set them each equal to 0 and solve. So you have a vertical asymptote where? Good. So we're looking for the graph with 2 vertical asymptotes, one at 3 and one at negative 2. That is definitely that one right there. Last one, number 4, 3 over x cubed minus 4x squared plus 3x. Haley, what'd you do first?
So I started by taking out an x.
Good. We're setting the bottom equal to 0, and she took out an x, so she's left with x squared minus 4x plus 3.
And then I factored, so then I did
X minus 3 and x minus 1. Good. She factored that thing. Those two numbers, they multiply together to get her 3, and they add together to get her negative 4. And so then she's going to have vertical asymptotes at x is equal to what values here? Matthew, what values are we going to have vertical asymptotes? 0, 3, and 1. Good. We just take each one, set it equal to 0. So letter B is the only graph we have left. Hopefully there's vertical asymptotes at 0, 3, and 1. There's one at 0. There's one at 3 or 1. And there's one at 3. Good. Those are the ones we want. Questions with vertical asymptotes? Hopefully not too difficult. The next thing that kind of goes with vertical asymptotes is finding holes. Okay. A hole in your graph can happen. A rational function has a hole when there are the same factors in both the numerator and the denominator. When you have the same factor in the numerator and the denominator, then we can find a hole. And we'll kind of explain what that looks like. If you were to graph this on your graphing calculator or using Desmos, it would not be visible at first glance. Okay, but it's there. Okay. A hole happens when you plug in a number and you get 0 over 0. Okay, not just 0 on bottom, but 0 on top and bottom. That is called indeterminate form. It is something we use quite a bit in calculus. Okay, we're not quite there yet, but we can understand the basics. If we get 0 on top and bottom, we would get a hole. So if you just look at a problem, it's a little bit harder to see. Oh, if I plugged in this, I would get 0 on top and bottom. A little bit harder than a vertical asymptote. So the first thing we always want to do if we're trying to find holes is we want to factor everything. So I got an x minus 3 on bottom. On top, I could factor that into x plus 4 and x minus 3. Is there anything that's exactly the same on top and bottom? X minus 3. Okay, that is where I'm going to have a hole. Because there's an x minus 3 on top and bottom, there's going to be a hole at x equals 3. Okay, that's what that tells us. What we get left over when we cancel that hole out, all you're left with is just this y equals x plus 4 equation. That's what the graph's going to look like. It's going to look like y equals x plus 4, but there's this hole happening at 3. Okay. If you were to plug 3 on top, you would get 0. If you were to plug 3 on bottom, you would get 0. That's why this hole is happening. Okay. So this is what we're graphing, right? It's just a line. It's x plus 4. I didn't give you the best graph of all time, but it's slope of 1, boom, 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 this way. Okay. So I would have this normal looking line. However, at 3, I would have a hole. There would be a hole right here in my graph that nothing is going to be graphed. Because if you were to plug in x is equal to 3, you would get 0 over 0. And that is not part of my domain because 0 over 0 is not a number. Okay, it's undefined. It's indeterminate. Makes sense with how that works. Let's look at letter B. So to find that hole, first thing you're going to do is factor and cancel and then see what you can do. Work with your neighbor, see what you can do with that one. Let's look. So in order to find holes, we always want to factor it first. So Aaron, hey Cox, what'd you do?
I took out 4x on top.
Good. 4x on top. So what would you be left with? Lovely. And then on bottom? X plus 5 and x minus 2. Great. So we're looking for a hole. A hole is going to happen when you have the same factor on top and bottom. We have that here. Okay. There is going to be a hole at x is equal to 2. What else would be happening on this graph? Negative 5 is going to be a vertical asymptote. We have a vertical asymptote at x is equal to negative 5. Both of those numbers, if you plugged in negative 5, you would get 0 just on bottom. If you plugged in 2, you would get on 0 on top and bottom. That would be a hole. Okay. Technically, not only can we find the hole, but we can figure out what the ordered pair of that hole would be. Because once we canceled out this, then we could plug 2 back in. And if I plug 2 in on top, I would get 8. And on bottom, I would get 7. Ugh. But there's going to be a hole at 2, 8 sevenths. So once you cancel out that hole, if you plug it back in, it'll tell you where that hole would occur. That's where you're going to draw the hole on your graph. Okay, let's do one more. Letter C, we are going to factor and solve here. So when we look at that thing here, Annika, what we want to factor, what can we factor the top of this into? X minus 4, x plus 1. Great. What about on bottom? Lovely. So we factored that out. Once we factored it, Eli, we're looking for a hole. Where am I going to have a hole here? At 4. I'm going to have a hole at x is equal to 4. What about a vertical asymptote here? Vertical asymptote at x is equal to 1. If you wanted to find where that hole happens, you would take 4 and plug it into this new equation without this x minus 4. So it'd be 5 thirds would be where that hole happens, 4 comma 5 thirds. Questions on vertical asymptotes or holes? All right, those are both fairly straightforward. Let's go to the backside. On the backside, we are doing long division like we learned in bell work, like you did back in 5th grade. Okay. Last chapter, we did synthetic division. If we wanted to divide 4x squared minus 3x plus 6 by x minus 2, you can. Okay. We could put 2 in the box. We wrote our leading coefficients, 4, negative 3, and 6. We dropped down the 4. We multiplied. We added. We multiplied. We got 4, 5, 16. What did the 4 and the 5 represent? 4x plus 5. Because it was an x squared polynomial, I took one of the values out. All right, it's cool. Doesn't really tell us much, though, because it's 16. It was not a 0, okay, even though it just doesn't mean a whole lot. Okay, so that gave us the ordered pair 2 comma 16, but it didn't give us a whole lot. We could do that same thing with long division. Okay, with long divisions, it's exactly what we did in bell work. You start off here and you look at the leading term there, x minus 2. Okay, and you ask yourself, x times what gets me 4x squared? And the answer is 4x. We put it up above. Once we put it up above, we're going to multiply it down. 4x times x gets me 4x squared. And 4x times negative 2 gets me negative 8x. And then just like we did in long division, we are going to subtract. We are going to change the signs. That's going to cancel. That gets me 5x. I bring down the 6. Then we repeat the process. We ask ourselves the question, x times what gets me 5x? The answer is 5. So we put a 5 right there. We multiply it down. 5x. 5 times negative 2 is negative 10. We change the signs. Cancels, it gets me 16. X times nothing gets me 16, so this right here is my remainder. So if you want to write it out, it's 4x plus 5 plus 16 over x minus 2, because 16 doesn't go into x minus 2 evenly. Okay, just like when we did bell work, we got a remainder of 3. We said that was like 3/4 because it didn't go in evenly. Okay, that is how we do long division. Notice it's exactly what we got when we did synthetic division, 4x plus 5 and 16. Synthetic division is a great answer for a lot of the times we do it. It doesn't always work, though. Okay, it doesn't always work. On letter A, we could do synthetic division. Okay, if we did synthetic division, we would be fine, but let's do it with long division. So I'm giving you an easier problem here. That way we can do some long division. So we're dividing by x plus 1. Underneath the division bar here, we're going to write x squared minus 9x minus 10. All right, I'm going to walk you through this again. So we start off by asking ourselves the question, x times what gets me x squared? X. So I'm going to put x up above, and then I'm going to multiply down. X times x is x squared. X times 1 is x. Notice that I'm putting them underneath the column that they belong. So like the x squared went under the x squared column, the x went in the x column. Okay. Once I've done that, the most important thing that students will forget today is you have to then change the signs. I'm subtracting, so I got to change both signs. And then I'm going to combine x squared and negative x squared. That goes away. Negative 9x and negative x, oh, that's negative 10x. And I can bring down the next thing, which is negative 10. Then we do it again. We ask ourselves the question, x times what is going to get me negative 10x? Negative 10. So I write a negative 10 up above. Then I multiply it down. Negative 10 times x is negative 10x. Negative 10 times 1 is negative 10. I'm putting them together. So what do I need to do when I put them together? Change the signs. Oh, it gets me nothing. It gets me nothing. It's a remainder of 0. So that does the same thing synthetic division does. It tells me that x plus 1 is a factor of this thing. Okay, x minus 10 is the remainder. Okay, it goes in evenly. So really what we just did was a really long and annoying way of factoring. right? If you were to factor this thing right here, you would get x plus 1 and x minus 10. If we did synthetic division, we would get the same thing. Okay, but that's all we did. We divided it out, and since it divided out evenly, it's factored. Questions on A? Let's go to B. So synthetic division works great, but you can't do synthetic division on a problem like this, when it's no longer a linear term down there, not just x plus 3 or x minus 4. When you get that x squared, that's when you have to use long division. Okay, so let's set it up. We're going to have to do long division here. We're putting x squared plus 1 on the outside, and on the inside it's x cubed plus 2x squared minus 3x plus 1. Okay, give yourself space, write it out nice and neat. If you try to press everything together is when you make a mistake. Then we're going to go through it. Okay, so Max, we start off by asking ourselves the question, x squared times what is going to get me x cubed? X. Good. So we put an x up above, and then we're going to multiply it back in. So x times x squared, x cubed, and x times 1 is x. Notice that I'm going to put that in the x column right there underneath the negative 3x. Abby, once I've multiplied it out, what do I have to do next? I have to subtract. Good. I have to change the signs. The x cubes cancel. That comes down. Minus 4x. If you bring down that 1, great. Nothing's going to hurt you. Okay, we bring down that 1. Then we're going to do it again. Okay. Megan C, what am I going to multiply x squared by to get me 2x squared? 2. So you're going to write a 2 up above. Then what do you do once you write it up above? Multiply. So 2x squared. And then 2 times 1 gets us 2. She's going to put it in her constant column. We're putting them together. So if we're putting them together, Kate, what do I got to do? Got to change the signs. 2x squareds cancel. This comes on down. 1 minus 2. Oh, that's negative 1. And we do it again. X squared times what gets me negative 4x? Nothing. X squared, you can't multiply x squared by something. This has a higher degree than this. That's squared, that's x to the first power. When that happens, you're done. That's a remainder. So my answer is x plus 2, and then I get a remainder of negative 4x minus 1 divided by x squared plus 1. Just whatever's left over here divided by whatever we started with. That's going to be our remainder. Doesn't mean a whole lot to us yet what that remainder does. It's just dividing it out. Okay, it's something you actually need in calculus again. It's kind of strange when we get that in calculus, but be ready for that. Questions with anything we did there? All right, let's set up number 3, or letter C, or whatever we called it. Letter C. Let's set it up. Okay, so negative x squared plus 9 goes on the outside. I've got 2x cubed. I've got 4x squared. Notice that I have 0x. Okay, so I need to leave a spacer 0 there. Make sure you got a plus 0 in there. Otherwise, it won't match up, and it just gets ugly. And then a minus 9 on the outside. Okay, take a second with your neighbor. Do long division. See what you get. If you get done with that one, you can go ahead and try letter D as well if you like. So, Aaron C, we got negative x squared. What do I need to multiply by to get 2x cubed? Negative 2x. So she's putting that up above here. Then we're going to multiply it down. What'd you get when you multiplied that down?
2x to the third minus 18.
Good. Minus 18x, and she's putting that in the right column to make this organized. Ella, once she's done that, what does she have to do next? Good. Subtract and change the sign. So we're bringing down what's left over, 4x squared plus 18x minus 9. Okay, then we just repeat the process. Kara, what do you have to multiply negative x squared by to get 4x squared? Negative 4. Then we multiply it down. What'd you get when you multiplied it down? And 36, good. Yeah, negative 36. It gets weird when you change your signs. You're good. And then Herman, what do I got to do next? Got to subtract. Got to change those signs. And so the 4x squareds cancel. The 18x comes down. And that is 27. How many times is negative x squared? What do I multiply negative x squared by to get 18x? Nothing. That's my remainder. So my answer is negative 2x minus 4 plus 18x plus 27 all over negative x squared plus 9. Show me with your fingers right now, 0 to 5, how good are you at long division? 0 is bad, 5 is great. 3s and 4s. All right, let's do one more. Letter D. We're setting it up the same. Okay. Negative x cubed plus 3x goes on the outside. Underneath, it's 3x to the fourth, 0x cubed, 0x squared, 0x, and then a plus 4. Take a sec with your neighbor if you haven't yet and do long division. Do it. We're setting this thing up. Lydia, negative x cubed times what is going to get me 3x to the fourth? Negative 3x. Good. Then you're going to multiply it down. So it's going to get you 3x to the fourth minus 9x squared once we've multiplied it down. Evan, what do I got to do next? Change those signs. We got to subtract it. So we're going to change those signs. Those things are going to cancel. This is 9x squared. Nothing to come down there, so I got a 4. Then I do it again. I ask myself the question. Negative x cubed times what gets me 9x squared? Nothing. So that's my remainder. Negative 3x plus 9x squared plus 4 all over negative x cubed plus 3x. That's just a remainder. Okay. We couldn't even do it twice. We could only go into once. Questions on D? All right. Let's go to letter E, or to the next one here. So the next set here, we're just answering a bunch of questions based on a graph. Okay. Understanding what asymptote looks like and work from there. The first question is not tough, but it's always one that slows us down a little bit. Domain and range. So looking at graph 28, talk with your neighbor real fast and describe what do you think the domain, what do you think the range are of that thing? All right, let's look. Anybody confident in their domain here? Confident in their domain? Don't all raise your hands at once. Sophia, what do you think?
I said all real numbers, but x can't be 0.
Yep. X can't be 0. Everything else. You've got these parabolas. This graph's going that way forever. This graph's going that way forever. The only place we're not going to have a graph is right here in the middle. Because what is happening at 0? There's a vertical asymptote at 0. And we do not touch, we do not cross vertical asymptotes. We're going to get really, really close to 0, but we're never going to actually be 0. Okay, so there is a horizontal asymptote at 0. I'm sorry, vertical asymptote at 0. That's why it's not part of my domain. What about my range? Starting at negative infinity until when for my range? Aaron? Negative 2. Good. Bracket on negative 2 because I actually reach negative 2 right there. And then what is your second one going to look like, Aaron? Good. From 2 to positive infinity. Okay, bracket 2 to infinity because we're going from here up and from here down, but nowhere in between there. Good. So that's the only really tricky part here. The rest is just doing it. Letter B says, are there any intercepts? Are there any intercepts on this graph? Nah, there's none. I don't touch the x-axis. I don't touch the y-axis ever. Okay. Letter C says horizontal asymptotes. Okay. A horizontal asymptote is going to be a line that as you get further and further to the right and further to the left, you're going to keep at that line always. Okay. As I go to the right and to the left, am I going towards a single number? No, it is going up and it's going down. So I'm not going to a single number. So there is no horizontal asymptote here. Okay. Letter D, vertical asymptotes. Yeah, we said that. Vertical asymptote at x is equal to 0. And then the last one, letter E, asked for an oblique asymptote. Oblique asymptote at. An oblique asymptote means a slanted line. Is there a slanted line that divides my graph? And as I work to the left and to the right, I'm going to stick with that line as I keep going. And so, yes, we have one. An oblique asymptote at y equals, what would the equation of that line be here? Negative x. It's just a sloped line. The y-intercept is 0. I'm down 1 over 1, down 1 over 1. It's oblique asymptote at y equals negative x. Questions on that first one? Let's go to the next one. Letter A. Domain, all real numbers. X cannot be plus or minus 2. range would be negative infinity to 0. Do I want to include 0? Yep. And 1 to infinity. Notice that I'm not including 1 there because I'm not reaching that horizontal asymptote. I'm going to get really, really close to it, but I'm not going to touch it. That was an easy one. Letter B, or that was not the easy one. Letter B, then we're talking about intercepts. Where do you think intercepts are going to be? X equals 0 and y equals 0 because we touch 0, 0. So we have we have an x intercept and a y intercept there. If you just wrote the ordered pair 0, 0, that would be fine. Letter C, we're doing horizontal asymptotes. Do we have a horizontal asymptote here on 29? Horizontal asymptote at x it's x equals now because we're doing horizontal lines. X is equal to what? 1. I'm getting close to 1. As I go this way, I'm getting 1. As I go that way, I'm getting a 1. That's a horizontal asymptote. Letter D, ask for a vertical asymptote. Yeah, I'm sorry. No. Good Lord. No. Just playing. Vertical asymptote's a y equals line. I do it too, just like you guys do. It's a horizontal asymptote because we cross the y-axis, so it's a y equals line. Sorry, my brain shut down. Vertical asymptote is going to be at x is equal to plus or minus 2. Letter E, ask for an oblique asymptote. Do I have an oblique asymptote on 29? No. Okay, try that one more time with that last one. See what you can do with that. So if we were doing domain, all real numbers, but x cannot be, show me with your fingers, what two numbers can x not be? X cannot be plus or minus 1. My range is all real numbers, but show me the values that range cannot be. You can be them all. Good. Because we're going down from the bottom to the top. There's no stopping in that middle one, so the range is all real numbers. X intercepts. I'm sorry, just intercepts in general. Where do I have an X intercept? 0. When do I have a Y intercept? Great. Then I did vertical asymptotes at plus or minus 1. We already said that. Horizontal asymptote at Y equals, where do I have a horizontal asymptote here? It's 0. Okay, so this is something you need to know. Oh no, I crossed 0. Doesn't matter on horizontal asymptotes. You can cross it. It's what's happening on the sides. So as I go to the left and to the right, I'm getting closer and closer to 0. That's what makes that a horizontal asymptote. You can totally cross horizontal asymptotes. You cannot cross vertical asymptotes. Is there an oblique asymptote here? No, we did good. That